Yes, hello Midhun. Welcome on Europedia platform. And let's start your snap, thermodynamic snap for your ONGC interview.
Yes, sir.
So Midhun, what is thermodynamics?
Sir, thermodynamics is, if we split the word thermodynamics, it's the interaction of heat. It's the study of interaction of heat. Thermo means heat and dynamics means motion. So it might be the study of heat in motion. Everything which is related to heat or temperature comes under thermodynamics.
Ajay, what is the difference between a perfect gas and ideal gas?
Ideal gas follows the ideal gas equation PV equal to MRT. A perfect gas may be whose Cp and Cv is constant.
So perfect gas is not ideal. Perfect gas is not going to follow that ideal gas equation.
No, sir. Perfect won't. Sir, I am not
Why
sure.
we are using that word perfect? So perfect, ideal.
Ideal will follow the PV equal to MRT relation, but
Is there is any perfect gas equation also?
maybe one PV by MRT Z equal to PV by RT, something like that was we have studied in 12th standard, but I don't remember exactly.
No, that Z is compressibility factor.
Oh, compressible. Okay, sir. Actually, I'm not that sure about difference between perfect and ideal gas.
No issue. What is calorific value?
So calorific value is the amount of heat released by a fuel. Uh, the amount of energy released by a fuel in its unit mass.
What is
Per
then
unit
specific heat? What is specific heat?
Specific heat is the amount of energy heat energy required to raise it. There are two kinds of specific heat for gases. For solids and liquid, only one is there. So for specific heat in general is the amount of heat required to raise the body's temperature by 1 degree Celsius or 1 Kelvin. If it is under constant pressure, it is Cp. If it is under constant volume, it is Cv for gases.
Suppose there is a gas in some piston center arrangement.
Yes, sir.
And the piston is free to move.
Okay, sir.
The gas is ideal gas.
Okay, sir.
Okay. So you are just moving the piston down at constant pressure.
Okay, sir.
So how can you show that process on PV diagram and TS diagram?
Yes, sir.
Just go ahead. Just show it on TS diagram first.
TS diagram. Sir, with paper, may I show?
Yes.
Constant pressure compression, no?
Yes.
It will be something like this TS 1 to 2.
So why temperature is decreasing? How it can decrease?
Temperature, because at sir, if it has to be maintained at constant pressure, if we compress, we are doing at constant pressure. If we compress, we are doing work on the cylinder. So work will go and increase the internal energy. So thereby increasing the temperature. But sorry, sir, I'm going wrong. Sir, because it will have to lose the heat to maintain the constant pressure, sir. If it is having that heat inside it, the pressure will increase, sir. If it does not lose the heat, it won't be any more constant pressure process. To maintain it as constant pressure, it will have to liberate heat. Otherwise, this temperature, if temperature increases, randomness of molecules will also increase. That will exert pressure on the cylinder. So pressure will also.
Mithun, your voice is very low actually now.
Sir, now am I audible?
Now fine. Keep it close to your mouth only.
Okay, sir. Fine. Sir, that is if we keep do it if we don't lose the heat, sir, it will not be
fine. Just tell me why entropy is decreasing then.
Entropy is decreased because heat is being liberated from the entropy is at constant pressure for a gas is Cp. We have three equations. In that equation, from that equation also we will get it as lowering. Entropy is decreasing. Otherwise, we
Actually,
can simply
these processes are reversible processes. Constant pressure, constant volume, frictionless.
yes, sir.
Pressure, heat rejection. That is a reversible process.
Yes, sir.
But entropy is decreasing.
Sir, entropy can decrease or increase for a entropy is for a cycle. Sir, entropy for a reverse entropy can decrease for increase or be remain same for a reversible process, sir. If heat is added, it will increase. If heat is liberated, it will decrease. But for a
how are you going to prove that this process is reversible?
Sir, if cyclic integral dq by t is equal to 0,
It's not a cycle. This is only a process.
Yeah, it is a process. So if we simply take the difference between the point 1 and 2 of entropy, if we get the same entropy difference, because entropy is a point function, and if those that difference
entropy is a property, and entropy change will be same between the same end state, whether you are taking the reversible process or irreversible process.
Entropy.
This process, whether it is reversible or irreversible, if you are having initial point, the entropy change will come out same.
Sir, we'll check that entropy change with integral dq by t. If it is if integral dq by t comes to be
why you are writing dq by t integral?
Because integral dq by t is for irreversible process will be lesser than that reversible process,
because this is a process. You need to mention here dq by t.
Yes, sir. dq by t. dq by t will be lower because delta S generation will also be countable in irreversible. So dq by t will be lower for irreversible. If it is irreversible,
so how you will find out that dq by t?
Sir, we'll have to find the heat liberated through process. If it is going through two paths, path A, if suppose A is reversible and B is irreversible, both A and B.
You are taking any other process? The process is there in front of you. You know the initial and final conditions. Pressure is constant, suppose 2 bar. Okay.
Okay, sir.
The initial temperature is suppose 400 Kelvin. Final temperature is 300 Kelvin, for example.
Okay, sir.
These things are known to you. Just find out just to prove that this process is reversible.
Sir, if we find the area of TS diagram, area under TS diagram, we get the heat. So if heat is equal to
let me give you some hint. You heard about entropy generation?
Yes, sir. Entropy generation.
How the entropy generation?
Entropy generates when it is an irreversible process.
So this process, the entropy generation will come out 0 or it will come out
zero, sir.
0.
Zero.
So how you can check that entropy generation is 0 or not?
Sir, ambient temperature into delta S universe. The change in total entropy change of universe, the system plus surrounding.
So just tell me how you are going to find out entropy change of system and how you will find out entropy change of surrounding.
System we can find out by those three equations. If suppose one equation CPLN T2 by T1 plus minus RLN P2 by V1, that in that P2 by CPLN T2 by T1 only will remain because pressure is constant, minus RLN V2 and V1 will go. So that is for system, for the piston cylinder system, and for surrounding we'll take MCP dt of heat liberator MCP dt divided by the ambient temperature, the surrounding temperature, dq by t. We add those two. If we get it as 0, then it is reversible, sir, because delta generation will be 0.
Acha, how you can define a reversible process?
A reversible process is if we it it can go back to initial stages following the same path without any loss in energy. Like their reversible should be frictionless and it should be very slow process. In
Acha,
each and
energy
every
तो loss कैसे हो सकता है? Energy is conserved, ना? We cannot create energy, we cannot destroy energy. Energy is conserved. Then what do you
sir,
mean by energy loss?
sir, energy can be transformed to other, like if friction comes, heat losses, heat, it will be converted to heat. So it heat will be liberated. That cannot be used, no. That will be, we have that also, that heat is a low grade energy, it will be gone. So every stage it should come back to the same initial position in reversible process.
Acha, what is vapor pressure?
Vapor pressure, sir, it is the pressure exerted by a gas when that gas is kept alone in it is the pressure exerted on a container if on a container by a gas if that gas alone is kept in that container.
Acha, how the vapor pressure of a gas changes with the increase in temperature?
With increase in temperature it will increase, sir. Vapor pressure will increase.
Vapor pressure will increase with the increase in temperature.
Yes, sir, because
Can you recall any of the equation which we use in thermodynamics, which actually establish some relationship between this P saturation and T saturation?
Sir, in psychometry, some equation is there, sir. No. Peace, sir. As I don't remember exactly, sir.
Okay. My last question to you, Mithun.
Yes,
Midhun,
sir.
sorry.
Yes, sir.
So, what is second law of thermodynamics? What is your understanding? Tell me something actually different. The understanding from your understanding you got after studying this subject thermodynamics. What is second law of thermodynamics?
Sir, it gives to arise. It gives to the arise of a new parameter known as entropy. It also gives us the quality of the energy. Like we cannot make a engine 100% efficient, or in other words, we cannot we cannot transfer heat from low temperature to higher temperature without the aid of an external working agent. So it in short gives us the quality of the energy we have, like and that is, it gives us the parameters such as available energy, irreversibility, and also.
Okay, Mithun, I think now I can provide you the feedback.
Okay, sir.
ठीक है आपका your knowledge is looking fine. Somewhere, at some of the questions you made some mistake in some of the
Okay.
questions, so those you need to correct. Otherwise you are looking comfortable. थोड़ा सा आप interrupted answer करते हो, so it is good to answer in a very continuous manner. Okay.
Okay,
So
sir.
थोड़ा सा, because I feel because this is your first snap, that may be that.
Yes, sir.
So if you practice more and more, then I feel you will come out of this kind of discontinuity actually, because when you are answering in a one go, so it will look
Okay.
nice actually, and the interviewer also he will feel yes, you are a confident guy, and very effectively you will be able to communicate with your subordinates or other colleagues, because those things are required, because all these positions are for a kind of what officer positions, है ना?
Yes, sir.
थोड़ा सा कॉन्फिडेंट रहना है मिथुन, और
Question.
एक फ्लो में बोलना है, इंटरप्टेड आंसर नहीं करने. It is good to think, you applied your mind, you tried actually getting the answer of each and every question. तो मेरे को ठीक लगा आपका overall, it's good.
Okay,
So
sir.
ideal gas, perfect gas is already ideal gas. So a ideal gas with constant CPCV, that is known as a perfect gas.
Okay, sir.
Okay, so all ideal gases are not perfect.
Okay, sir.
But all perfect gases are ideal.
Okay, sir.
Because what is a perfect gas? A ideal gas with constant CPCV. Got the point?
Okay, sir.
Then I asked you some of the question related to a process that initially you faced difficulty, but finally you answered, है ना? So I hope some idea you got. Like they can give you some kind of process. They can ask you some of the related question, how you will find out the heat transfer, work transfer, entropy generation. तो
Okay, sir.
थोड़ा सा आपको अप्लाई करना है
हाँ,
जो concepts आपने gain किए, and I hope you scored very well in GATE examination, so you all are having some kind of good understanding of these subjects, but in interview you need to apply your minds, है ना? तो क्वेश्चन
okay,
को समझना है और उसको सोचना है. कांस्टेंट प्रेशर प्रोसेस में क्या होता है, व्हेन यू आर कैरिंग आउट कांस्टेंट प्रेशर एक्सपेंशन और कंप्रेशन. कांस्टेंट प्रेशर का एक्सपेंशन व्हेन यू आर कैरिंग आउट मींस यू आर कंटिन्यूअसली एडिंग द हीट.
yes, sir.
You are carrying out compression means volume is decreasing but pressure is constant. It means the temperature is going to decrease, and
Yes, sir.
that will be there only if you are rejecting heat.
Yes, sir.
तो वहां पे हमें क्या करना पड़ेगा, कंटिन्यूअसली हीट रिजेक्शन करना पड़ेगा, अदरवाइज द प्रोसेस विल नॉट रिमेन कांस्टेंट प्रेशर. इफ यू आर कंप्रेसिंग, its pressure will start building up, its pressure will
Yes,
increase. So if you
yes,
want to keep the pressure constant, you need to cool the system,
yes,
and
sir.
that you need to do, you will be able to do only by rejecting the heat.
Yes, sir.
तो एंट्रोपी कैसे डिक्रीज करेगा, बिकॉज सर वी आर कूलिंग इट, because we are cooling it, temperature is coming down, pressure
Yes,
is constant, so obviously the entropy for the system is going to decrease, but for surrounding it will increase. And sir,
yes.
the sum of entropy change of system surrounding, that will be zero,
Okay.
because the process is reversible.
Yeah, reverse.
थोड़ा सा confident रह के उसको आंसर करना है. For system it will be negative, for surrounding it will be positive.
Yes, sir.
Or then I asked you about this second law. There are so many things you can mention in second law. Like second law gives us the concept of entropy. We get the direction of a process, in which direction a process is going to execute. A real
Yes.
process is going to execute in the direction of increase in entropy of the universe.
Yes.
Okay. In a real process, there must be always some exergy destruction takes place. So energy loss से क्या मतलब है sir? We are losing the quality of energy. Energy is conserved, but what we are losing, sir? We are losing the work potential.
Okay, sir.
So here you are having some work potential. Here suppose some process is taking place. So from 1 to 2, what we are losing the work potential.
Yes, sir.
Suppose there is a water in a dam. Water in a dam is having some work potential.
Yes, sir.
But when you are utilizing that water energy, potential energy of the water in running some turbine, so what power you are getting at the turbine, that is equal to that water power in the dam or less than that?
Less than.
Obviously less
Least.
than that, because we are
Yes.
losing energy. What
Yes.
we are losing, we are not energy loss. Energy we cannot create, we cannot destroy. But what we are losing the work. We are losing the work potential. Okay, loss of available energy, and that loss of available energy is known as what? Irreversible. So
Okay.
in the real process, always there must be some loss of energy, loss of available energy.
Available.
Fine.
Okay, sir.
चलो अच्छा, वो कंप्रेसिबिलिटी फैक्टर होता है, वो क्या होता है? कंप्रेसिबिलिटी फैक्टर इफ इट इज इक्वल टू 1, द प्रोसेसेस आर नोन एज द गैस, द पर्टिकुलर गैस इज नोन एज आइडियल गैस. So for a real gas, compressibility factor may be greater than 1 or less than 1.
Okay, sir.
चलो
Okay.
ठीक है, मेरे को ओवरऑल मिथुन अच्छा लगा, और मेरे को लग रहा है कि आप 2-4 स्नैप और दोगे तो देन यू विल हैव मोर कॉन्फिडेंस, मोर क्लियरिटी, एंड यू विल बी इन अ वेरी गुड बेटर पोजीशन टू कन्विंस द इंटरव्यूअर.
Okay, sir.
ओके, गुड लक मिथुन.
Okay, sir. Thank you, sir. Thank you, sir.